Okay, so today we will be automating Terraform provisioning and with the code pipeline and code build. This is the architecture diagram where we will be uploading our Terraform manifest file on GitHub, and using code pipeline we will be building a dev environment and a staging environment. In the code pipeline we will be using an email notification using SNS, simple notification service. Coming to the dev environment and the staging environment, we will be creating a VPC EC2 instance in private subnet and also in the public subnet as a bastion host, the application load balancer, NAT gateway, internet gateway, and also the SNS topic for the email notification, and also the SNS topics for auto scaling group. This is the Terraform manifest files, the provider block, the variables, local values. This is the VPC module. We are giving it name, CIDR, availability zones, public subnet, private subnets, database subnets, enabling NAT gateways. Going forward to the security group for the bastion host, we are providing the SSH access port 22. This is the security group for our private instance. We are providing ingress rule of 22, SSH access, and also HTTP AT access from our CIDR block. This is our CIDR block 10.16.00/16. This is the security group for our application load balancer. We are providing ingress rule of 80 and 443 for HTTP and HTTPS respectively, and this is a CIDR block. This is the EC2 instance, which is the bastion host. The elastic IP. This is the data source, the AMI Linux 2. These are the null resources. So this is our application load balancer module. We are giving it a name. Load balancer type is application. VPC ID, subnets, security groups, HTTP listeners, target group. This is the auto scaling group for the launch template, the launch template resource. We are giving a name prefix, description, image ID, instance type, block device mapping, monitoring, and tag specification. This is the auto scaling group resource. We are giving it a name prefix, maximum size, minimum size, desired capacity, VPC zone identifiers, target group ARNs, and also the health check, launch templates, instance refresh, tags, SNS notification topic for our auto scaling group. We are giving it an subscription. The protocol is email. We are giving it AWS auto scaling notification. This is the auto scaling policy for our target tracking, where there is this auto scaling group name, estimated instance warm up, target value. This is the configuration for the target tracking configuration. And this is our scheduled auto scaling policy. We're increasing at 9 p.m. UTC time, and also we are decreasing at 5 p.m. UTC time. Now let us go to the build spec, which will be used in our code build. Also, first is a variable, then there's parameter store. This falls into the environment variables. Then goes the phases. The first phase is to install. The runtime version is Python 3.9. Commands, this is the command Terraform version. Then we are installing then we actually wget the release of Terraform, and then we will be installing Terraform. We will be unzipping it and then moving Terraform to our local user bin. Then we will be building our Terraform manifest files using the Terraform binary. We will go into the Terraform manifest folder, and then Terraform version, Terraform init, Terraform validate, Terraform plan, and also the Terraform command, which is the Terraform apply command with the auto approve. And also we are giving it a var file dev.tfvars. This is the dev.tfvars, where we are defining our environment, the VPC name, VPC CIDR blocks, availability zones, public subnet, private subnet, database subnet, our VPC database subnet group, our instance type, instance key pair, private instance count. The same story is for our staging. All the things that are here defined for our staging also. The only difference is that here we are taking the -var -file equals to stage.tfvars. So this is our stage.tfvars, where our environment is staging. Our VPC name is my VPC. Okay, so now we are in our AWS console. The first thing to do is to go to our S3 bucket. Here we will be creating our S3 bucket for Terraform state storage. Let us create a bucket. Let's give it a name, AWS CodePipeline CodeBuild IAC Terraform MNM. Let's keep it at default and create bucket. Let us go inside the bucket and then create a folder. Here we will be giving it a folder name of IAC AWS Terraform. Create folder, and inside this folder we will be creating two more folders. One is for dev and the other one is for staging. Folder name is stage. Okay, create folder. So this is done. Let us now go to our DynamoDB, where we will creating two tables for our Terraform state locking. Let us create the first table for our development, our dev IAC AWS Terraform dev tf state. For the partition key, doing a lock ID, keeping it as a string. Other thing as default, create table. Now let us create one more table, and this time we will be creating it for the staging one, IAC AWS Terraform stage tf state. Again, for the partition key, our primary key, we will be doing a lock ID, keeping it as string. Going forward, we will be creating this table. Now it is creating. Let us go to our third step. Now we will be going to our systems manager parameter store, and we will be creating two of our parameter store. Now I have actually created the parameters here for /CodeBuild/my AWS access key ID, where I have kept it the type of string, secure string, and the value. And also let's go to the parameter store and the second parameter, which is /CodeBuild/my AWS secret access key. Also I have kept it as a secure string and give it a value. Now let us go to our AWS developer tools. We have to create a link with our AWS and GitHub, as our manifest files are uploaded to GitHub repository. Let us go to the settings, connections, create connection, GitHub, connection name. Let us give as a connection name of M&M GitHub connection CI/CD, connect to GitHub. Okay, now we will do install a new app. Only selected repository, and the name of my repository is automated Terraform provisioning. Install. Let me give my password. Confirm. So okay, that has been connected. Let us connect it. So the connection of AWS has been created successfully. Okay, now go to the developer tools, then let's go to pipelines and let's create a pipeline. Let us go and create a pipeline. AWS CodePipeline and also tf-mm new service role. Allow AWS CodePipeline to create service roles so it can be used with this new pipeline. Okay, next. The service role name already exists. Let us change here. Let us do a 2. Okay, next. For the source provider, we will be using GitHub version 2. For the connection, we have already created a connection, AWS GitHub connection CI/CD. Repository name is automated Terraform provisioning. Branch name is main. Next. For the build provider, we will be using CodeBuild. Region is US East 1, Northern Virginia. For the project name, we will be creating a project. Let us open it up. Now we will be creating a CodeBuild project. Let's give it a name. Okay, description, let's paste in the same. Managed image. Operating system will be Amazon Linux 2. Runtime is a standard. Image. For image, let's go with the x64, x86 64-bit. version 4. It will create a new service role for us. Build spec. Okay, now we will be giving it a build spec which we created. Build spec -dev .yml. Continue to code pipeline. Okay, so it has created AWS CodeBuild dev code build. Let us go. It will be a single build. Next, deploy provider. No, we will be skipping this stage. Yes, skip. Let's review the pipeline name, add source, add build stage. Here we added our AWS code build, and let's just create a pipeline. So it has successfully created pipeline for us, and it is the source is in progress. Let us wait. So the source is succeeded. Now it has gone to the build stage, where it will be building our Terraform manifest file for the development environment. Let us view the logs, and okay, yes, this was as expected. The code build IAM service role needs access to our SSM systems manager parameter store to have a get parameter policy on it. So let us give it. Let us now go to IAM. As you can see, it also gives us the role that needs permission. So this is the role, code build AWS code build. Let us copy, go to roles, search the role here, and this is the role that it created. Here we have to add the permission, and for that let us go to policies. So here I have created a SSM get parameter access. It is a very simple. Let me show you in JSON format. So this is a simple. Effect is allow, action is SSM get parameters, and resource is all resources. So what I will do is I will add permission, attach policy, and select the SSM get parameter access. Go down, add permissions, and the policy has been attached to our IAM role for the AWS code build. Now let us go again to the code pipeline. For it to restart the code pipeline, we have to go here, release change, and click on release. This time it will restart its code pipeline, and let us see. Okay, so the source has been successful. Now it is building. Let us view the logs. Let us go down. So as you can see, Terraform has been initialized. It is giving Terraform plan. Yes, it's a Terraform plan command. Now let us see. I think it has started creating the Terraform apply auto approve. Yes, it is creating VPCs in our subnets. Let us wait till all the resources are ready. So here we can see it had given us the apply is complete. The resources, 55 resources have been added. These are all the outputs that is given us, and the build status is succeeded. Let us close, and as we can see, the pipeline has been successful. Okay, now let us go and go to our VPC and EC2 instances. Let us see that all the resources that we asked for in our Terraform manifest files have been created. So we can see that in the VPC it has created one more VPC. One is the default and other is our VPC. So yes, DevOps dev custom VPC stage. Now let us go to the NAT gateway. Again, these are all the subnets. Okay, so here on the EC2 dashboard, we can see we have 3 running instances. Let me show you. 2 in the private subnet and 1 is the bastion host, all in development. For our auto scaling group, yes, we are using the auto scaling group. Desired 2, minimum 2 and maximum 10. Activity, both are successful. Let's go to the load balancers. In our load balancer, its application status is active, scheme is internet facing. In the listeners and rules, we have a target group. Let's go to the target group. So target group is instance, protocol is HTTP 80, and for our targets it should have a total targets of 2. Both are in healthy state, and for our targets, these are the EC2 instances in our private subnets. So all the things are running as expected. Now let us edit this code pipeline, and we will be adding a new stage, which is for the email approval. Let's give it email approval stage name. Add action group. Action name is email approval. Action provider is manual approval. SNS topic is this is our SNS topic, code pipeline email approval, which I have created beforehand. I will show you. Okay, now done. Let us now save. After that, we will be adding another stage to this code pipeline. After the email approval, we will be having a build stage, add stage, add action group, action provider is CodeBuild, we will be going for the source artifact. For the project name, here we have to create another project, another CodeBuild project. Let's give it a name, AWS CodeBuild stage v2 M&M. Let's give it the same description. Okay, managed image, Operating system will be Amazon Linux 2. Runtimes will be standard. Image, let's go for the same image that we used in the dev stage. New service role, yes, this is will the service role, and also we have to attach the policy for systems manager parameter store also in the next step. Okay, we will be using a build spec file, and here we'll be giving it a name, build, if I can spell it, build, build spec hyphen stage dot yaml. Okay, continue to code pipeline. Okay, successfully created in CodeBuild. It will be a single build. Let's give it a done. I think that's pretty much it now here. Okay, we have created a build stage. Now let us go to the roles again. Let me refresh the roles. Let's search. This is the v2 that it created for our staging. Again, let us refresh and add permission, add attach policy. We will be attaching SSM get parameter access. Again, going forward, add permissions. The policy was successfully attached to role. Here we can see. Now let us go forward and again save. So in the pipeline now we have 4 stages. First the source, second is build for the development, third is the email approval, and fourth is our build for our staging. Now let us go and release change. Now it will start from scratch. Pick our source from GitHub repository, then do a build of our Terraform manifest file for the development environment. So the first step has been successful. Now to the second step. So let us return when the second stage is successful. Okay, so the build for our development stage has been successful. Now for the email approval, we can click on review and say approve, and the stage has been approved. Now to the build stage, the last step in our code pipeline. So let us return when this build also is in the successful stage and it has built all the resources for the staging. Okay, so the apply has been complete. All 55 resources for the staging environment has been added. This is all the output that is given us. The build stage is succeeded. Let's close it and let's wait. It will appear successful in a moment or two. Let us refresh this page. Okay, so as we can see, our build stage is now in the successful stage. Okay, let's go to the VPC management console, refresh, and as we can see, we have 3 VPCs. One is for the development and another is for the staging, dev and staging. We have subnets also for the staging and for the development. We have route tables. We have internet gateway for dev and one is for staging. This is the default one. Elastic IPs. NAT gateways. Okay, let's go to the EC2 instance management console, and here we can see we have running. Let us yes, we have instances with there are 6 instances that are running. Two bastion hosts, two for staging and two for development. Let us go to the launch template. We have two launch templates, one for development and the other for staging. Let us now go to the auto scaling group. One is for staging and one for dev. Let's go to the staging one. Okay, desired minimum and maximum, our activity, automatic scaling policies that we created, schedule actions, and our dynamic scaling policies. Okay, now let us go to the load balancer. We have yes, we have two. One is for development and the other is for staging. Again, application, listener rules, and let's go to the target group. And in the target we have total of 2 targets, both are healthy. This is the instance IDs. Both are of DevOps staging. Okay, now we have to destroy the infrastructure, which is also we will be doing through automation. And let us go to the build spec, and for the TF command we'll be changing it to from apply to destroy, and the same thing we will be doing for the build spec staging. Okay, so what we will do is we will be committing and pushing it. Destroy. Let us commit. Let us now push the code. Okay, go to the pipeline just now, and it has been created. The pipeline has started. The first stage of source is in the progress. What this will do is it will destroy our development environment, also the staging environment that we created via the Terraform manifest files and all with the help of CodePipeline. So the first stage has been successful. So the build stage is the second stage is in progress. Let us return when it is completed. So the second stage, which is the build for the build code build, our development stage has been successfully deleted, and now it has gone to our approval, waiting for approval, review. Let's approve it. Approve. So the email approval was approved. Okay, now it has gone to the last step in our code pipeline, and it has started destroying the staging environment. Let us wait till all the resources has been destroyed. Okay, so our last step in our code pipeline, which is the destruction of our staging environment, has been completed. Now let us go to the VPC and see if our VPC has returned to the 1, which is the default VPC. Our subnets is 6, which is the default subnets. Let us go to the EC2 dashboard, and as we can see, we have 0 running instances. and auto scaling group has gone to 0. Load balancers has gone to 0. So I think that's pretty much it. Thank you for watching.